All right. Welcome back to the deep dive. Today we're going to be really getting into some meaty stuff.
Yeah, I'm excited for this one.
Yeah. So AIX security. This is a big one.
Yeah.
Our listeners have pointed us to some pretty hefty IBM documentation, on the core AIX security, and also some stuff about the cryptographic hop processor architecture and CCA.
Right.
And our goal with this deep dive is really to take all that and kind of distill it into a clear introduction to the fundamental security concepts you're going to encounter in AIX. So, if you're new to the platform, we want this to be your kind of express route to understanding how it does security without getting too bogged down in all the little details.
Yeah, and I think it's really important to kind of get a good handle on the basics and the foundations before you can really dive into the more complex stuff.
Right, absolutely.
So we're going to be looking at things like how the system authenticates users, how it controls access to files and resources, how it monitors system activity for security events, and then some of the tools that are available for establishing and maintaining a good security posture.
So basically everything you need to know to start locking things down.
Pretty much, yeah.
Okay. Well, I think a natural place to begin is with how the system knows who's trying to access it in the first place.
Right, yeah. User authentication.
User authentication.
That's the first step. And at the very foundation of that are user accounts.
Right.
And in AIX, each user account is assigned a unique numeric identifier, the UID.
The UID. Okay.
And this is really important because if two accounts somehow end up with the same UID, the system will treat them as the same account.
So that's like having two keys to the same lock.
Yeah, exactly. You don't want that.
Not good.
So absolute UID uniqueness, that's a key takeaway here.
Got it. Now, I remember back in my early UNIX days, messing around with the etc. pass file. Is that still where this information lives?
Yeah, the etc. file has been around for a long time.
Yeah.
It's a simple text file.
Right.
Each line of the file contains information about a single user account.
Okay.
It's all colon separated.
Yeah.
And it includes things like the username, the encrypted password, at least in the older systems, the UID, the GID, which is the primary group ID for the user, and then some other stuff like the user's full name, their home directory, and their login shell.
So it's like a one-stop shop for user information.
Yeah, pretty much.
Okay.
You might see a line in there that looks something like this, root.0.us or bink-ish.
Okay, I remember those.
Yeah. And you see that exclamation point in the password field.
Yeah.
That usually means that password authentication is disabled for that account.
Got it. Okay. Now, speaking of passwords, I know that the traditional UNIX encryption, it's not exactly Fort Knox anymore, right?
No, it's definitely not.
Yeah.
With the increase in computing power over the years, crypt has become susceptible to brute force attacks.
Right.
And AIX recognizes this, so it provides a much more robust alternative. The loadable password algorithm, or LPA.
Okay, LPA. And is that something that's enabled by default, or is that something that you need to turn on?
So you configure the system-wide default password encryption algorithm in the etc. security login.cfg file.
Right.
And specifically in the ustanza.
I see stanza. Okay.
And there's an attribute called pw algorithm.
Yeah.
That's where you define it.
Okay.
So you can specify the name of an LPA stanza that's defined in the etc. security pw.dalg.cfg file. Or if you absolutely have to, for compatibility reasons, you can set it back to crypt.
So you're saying don't do that unless you absolutely have to.
Right. Yeah. I mean, like if you have some really, really old applications that depend on the traditional crypt method.
Got it. So, setting PW algorithm is set to 2556 in etc. security login.cfg would enforce that stronger algorithm.
Right. Exactly.
Yeah.
For all subsequent password changes.
Okay. Good to know. And the documentation also talks about password aging and things like that. So are there ways to, make sure that passwords don't get stale?
Yeah, AIX provides a number of attributes that you can use to manage password aging and some other related security measures.
Okay.
So, you have things like Maxage, which lets you set a maximum lifespan for a password. So you can force users to change their passwords, every 90 days or whatever.
Right, right.
And then there's Menage, which prevents users from changing their passwords too frequently, which can sometimes lead to them choosing weaker passwords.
Right, because they can't remember what they just changed it to.
Exactly.
Yeah, yeah.
And then there are also settings that you can use to manage login attempts. So like login retries, which lets you specify how many times a user can enter an incorrect password before their account is locked.
Right.
And then login disable, which, well, actually, after login retries is exceeded, the login disable kicks in and actually disables the account
Okay.
temporarily.
Huh.
And then login readable, which specifies the duration of the lockout.
Okay, so you can like totally lock someone out if they keep trying to, guess passwords.
Yeah, exactly.
Okay.
And then there's one more attribute called PW warn time,
Okay.
and that lets you specify, how many days before a password expires that the user starts getting warning messages.
Oh, that's nice. It's like, hey,
Yeah, little reminder.
change your password. So yeah, so a lot of good tools there for really kind of managing the whole password lifecycle.
Yeah, absolutely.
Okay, great. Now, shifting gears a little bit, I noticed that the documentation talks quite a bit about the importance of protecting usernames and passwords from being exposed.
Right.
And even something as simple as a .NET Trestric file can be a security risk.
Yeah, that's right. So .NET DRAC files are files that users might create to automatically provide login credentials for services like FTP.
Right.
But the problem is they're stored in plain text in the user's home directory.
Oh, not good.
Yeah. So if an attacker gains access to that file, they've got the credentials right there.
Right, yeah.
So the documentation suggests using Kerberos as a more secure alternative.
Ribera, yeah. With
And Kerberos provides, strong encrypted authentication without storing passwords in plain text.
Right, so it's a much more secure way to handle that.
Yeah, absolutely.
Okay, now, what about preventing accidental or malicious creation of user or group accounts with the same ID?
Right.
What kind of mechanisms does AIX have for that?
So AIX has a couple of safeguards in place to prevent UID and GID collisions.
Okay.
So when you use the Macusa or Contegroup commands to create new accounts, they automatically check the specified registry to make sure that the ID that you're trying to use isn't already in use. And that registry could be, local files, or it could be an external directory service like ADFP.
Got it.
But then you also have the distinctive attribute.
Okay.
And this is configured in that sort of security login and CFG file.
Right.
In the ES2 stanza.
Uh-huh.
And this attribute, if it's set, it tells the system to check all configured registries for ID uniqueness during account creation.
So it's like a double check.
Yeah, exactly.
Just to be extra sure.
Right. It's especially important in environments where you have multiple user and group registries.
Okay, so that's how AIX controls who can get into the system. What about, once they're in, what can they do?
Right. So now we're talking about access control.
Access control, okay.
And AIX uses discretionary access control, or DAS, as a fundamental security mechanism.
Okay. DHEC. Got it.
And this basically means that the owner of a file or directory has the authority to determine who else can access it and what kind of access they have.
Okay, so the creator of the file is the one who's calling the shots.
Exactly, yeah. They have the discretion to control access to that resource.
Okay, and I know that access control lists, or ACLs, can also be used to manage permissions. How do those fit into the picture?
So ACLs are an extension of the traditional UNIX permission model.
Okay.
And they let you define specific access levels for individual users or groups on particular files or directories.
Okay.
And AIX supports two main types of ACLs.
Yeah.
AIXC and NFS4.
Okay. Two different flavors.
Yeah. AIXC is typically used for local file systems, whereas NFS4 is designed for network storage environments.
Okay, so let's dig into AIXC ACLs first. What are the key things to know about those?
So AIXC ACLs, they consist of two parts: base permissions and extended permissions.
Okay.
The base permissions are the standard UNIX permissions, owner, group, and others.
The usual suspects.
Yeah, and then the extended permissions are where you can get more specific.
Oh.
You can define access rights for individual users or groups beyond those basic three categories.
So it's like, a more fine-grained level of control.
Exactly, yeah.
Okay. And what about the actual syntax of an AIXC ACL entry? Like, how do you actually write one of these things?
So typically an AIXC ACL entry specifies a user or a group followed by the mode, which indicates the permissions that are being granted or denied.
Okay.
So for example, an entry like user.john.rw- would grant read and write access to the user John.
Okay.
And group.developers.r would grant read access to members of the developers group.
Got it.
And you can also explicitly deny permissions.
Okay.
So for example, group.auditors
Yeah.
would deny all access to the auditors group.
Okay, so you can get really specific with who can do what.
Right.
All right, and what about NFS4 ACLs? How do those differ?
So NFS4 ACLs, they're a little bit more involved.
Okay.
They have a more structured approach, and that's because they're designed for compatibility with the Network File System version 4 protocol.
Right, so they have to play nicely with NFS. Okay.
They have a specific format that includes an identity, which specifies a user, a group, or a special who string.
Who string? Okay.
Yeah. So that could be something like owner at C, for example.
Okay.
And then there's an AC type, which is either allow or deny.
Right.
And then there's an AC mask, which defines the precise permissions that are being granted or denied.
Okay.
And that can include things like read data, write data, execute, delete, and a whole bunch of others.
So it's much more granular.
Yeah, it's very detailed. And then you can also have optional ACE flags, which control how ACL entries are inherited by child objects.
Okay, so a lot more moving parts with NFS4 ACLs.
Yeah, definitely more complex.
Okay. Now, the documentation also talks about role-based access control, or RBAC.
Right.
What is that all about?
So RBAC is a more advanced way of managing privileges.
Okay.
Traditional UNIX systems, you were either a regular user or you were root.
Right, kind of all or nothing.
Yeah, all or nothing.
Okay.
And RBAC provides a more granular approach
Okay.
based on the principle of least privilege.
Least privilege. Yeah.
Right. So instead of granting a user full root access,
Right.
you assign them specific roles that grant them only the authorizations they need to perform their tasks.
Okay, so it's like, you don't give everyone the master key to the whole building. You just give them the key to their office.
Exactly, yeah. It minimizes the potential damage if an account gets compromised.
Right. If someone gets a hold of that key, they can't get into the whole building.
Right.
They can just get into that one little spot.
Exactly.
Okay, so how is RBAC actually structured in AIX?
So RBAC in AIX is based on a few key databases.
Okay.
You have the authorization database, which dictates what privileged actions actually exist on the system.
Okay.
Then you have the role database, which defines which authorizations are bundled into specific roles.
Okay, so the authorization database is like the list of all the things that you could possibly do.
Right, yeah, all the privileged things.
All the privileged actions. And then the role database says, okay, this role can do these 3 things.
Right, exactly.
And this role can do these 5 things.
Yep, and then you have the privileged command, device, and file databases.
Okay.
And these databases specify which commands, devices, and files require certain authorizations to be used.
Okay, so it's like, okay, if you want to run this command, you need to have this authorization.
Right. If you want to access this device, you need this authorization,
Yeah.
that kind of thing.
Okay, so now the documentation mentions something called enhanced RBAC mode. What is that all about?
So enhanced RBAC, it introduces a hierarchical naming convention for authorizations.
Okay.
So all the system-defined authorizations, they reside under the A top-level authorization.
Okay.
And then administrators can create their own custom authorizations under a new top-level parent. And that makes it much easier to organize and manage authorizations, especially when you have a lot of them.
Right, so it's like a tree structure.
Yeah, exactly.
Okay.
An enhanced RBAC also introduces the concept of role sessions.
Role sessions.
Yeah. So a user that's assigned to multiple roles, they can activate only the roles they need for a particular task.
Okay, so it's not like they log in and they automatically have all their roles active.
Right. They have to choose which ones they need.
Okay.
And there's a limit to how many roles can be active at once. It's 8 by default.
Okay.
But that can be configured using the max roles attribute in etc. security login.cfg.
Right, so you could bump that up if you needed to.
Yeah, if you had a user that needed to do a lot of different things.
Oh, wait. Yeah.
And some roles can also be designated as default roles.
Default roles. Okay.
And those are automatically activated for a user when they log in.
Okay, so those are like the roles that they always need to have active.
Right.
No matter what.
Yeah, just for convenience.
Okay, that makes sense. Can you give me some examples of some of these system-defined roles?
Yeah, sure. So 2 of the most common ones are SA, which is the system administrator role,
Okay.
and SECADM, which is the security administrator role.
Okay, so what kinds of things can someone with the SAY role do?
So the SA role typically encompasses tasks like user account management, file system administration, software installation and updates, and control over network daemons.
Okay, so that's pretty powerful.
Yeah, it's a pretty broad role, but it's important to note that the SARE role doesn't actually include the ability to set passwords for other users by default.
Oh, interesting. So they can create accounts, but they can't set the passwords.
Right. That's usually handled by a separate role or authorization.
Okay. And what about the SecAd role? What can they do?
So the second role is responsible for maintaining the system's security configuration.
Oh.
So that includes things like assigning users to groups and roles and authorizations, and managing security attributes on system objects like ACLs and ownership.
Right. So they're like the gatekeepers of security.
Yeah, pretty much.
Okay. So if I want to assign one of these roles to a user, how do I do that?
So you use the chooser command to associate roles with a user account.
Okay.
For example, the command chooser roles, so AGIM username, would assign both the system administrator and security administrator roles to the user username.
Okay, got it. And then when that user logs in, they can use the role command to activate the specific roles they need.
Exactly.
Okay, great. The documentation even mentions the possibility of disabling the root user account in enhanced RBAC mode.
Right. That's a pretty big deal.
Yeah, it sounds pretty radical. Why would you want to do that?
So by disabling the root user account, you eliminate that single point of failure.
Right.
You know, that one account that has all the power.
Right. The keys to the kingdom.
Exactly. And instead, all administrative tasks have to be performed by users who have been explicitly granted the necessary privileged roles.
Okay, so it's like a separation of powers kind of thing.
Yeah, and it makes it much harder for an attacker to gain complete control of the system if they manage to compromise a single account.
Right, because even if they get into one account, they still don't have all the privileges.
Exactly.
Okay, that makes a lot of sense. Now, what about managing security across multiple systems? Like, let's say you're using LDD for centralized authentication.
Right. So for that, AIX provides domain RBAC.
Domain RBAC. Yeah.
And you can define security domains, you know, like a local files in LDP.
Okay.
And then you can manage authorizations and roles and user assignments within and across those domains.
Okay, so it's like a unified view of security across multiple systems.
Right, exactly.
Okay.
And there are some commands that you can use for that, like imdum, elsdum, and esdum. And then there's also the sequorder attribute in the ssettings-control.conf file, which specifies the order in which these domains are searched for security information.
So you're saying if you had it set to check LDT first and then local files, it would look in LDP first, and if it didn't find what it was looking for, then it would check the local files.
Right, exactly.
Okay. Now, one last question on RBAC. It seems like applications themselves need to be aware of these authorizations.
Yeah, that's a good point.
Is that right?
Yeah, so applications that, that might have traditionally relied on checking the user's UID or GID to determine if they could perform a privileged operation,
Right.
they should really be adapted to use authorizations instead.
Okay.
And AIX provides APIs, like checkauths, that allow applications to explicitly verify if the running user has the authorization they need to perform an action.
Okay, so it's a more secure way to handle those privileges within applications.
Yeah, much more robust.
Okay, so we've talked about who can access the system and what they can do once they're in. But how does AIX actually monitor and record security-relevant activities?
Right, so now we're talking about auditing.
Auditing, okay.
And the main purpose of auditing is to detect security-relevant events.
Okay.
Things like successful or unsuccessful attempts to access resources, any actual or attempted violations of security policies, that kind of thing.
Right, so it's like keeping a log of who did what and when.
Exactly.
Okay.
And in AIX, the detection of these events is a distributed process.
Okay.
So the kernel itself, as well as trusted programs, are responsible for identifying these events and reporting them to the audit logger.
Okay, so it's not just one central place that's doing all the monitoring.
Right, yeah. It's happening all over the system.
Okay, and then what happens to those events once they're reported to the audit logger?
So the audit logger assembles what's called a comprehensive audit record.
Okay.
And that includes a header, which contains general information about the event, like the timestamp, the user involved.
Right.
And then a trail, which contains the specific details related to the event.
Okay.
And that whole record is appended to the kernel audit trail.
Kernel audit trail. Okay.
And AIX provides two main modes for storing this audit trail.
Okay.
Bin mode and stream mode.
Two different modes. Okay.
Yeah.
So what's the difference between those two?
So bin mode writes the audit trail to a pair of alternating files.
Okay.
And that provides redundancy and long-term storage.
Right. So if one file gets corrupted, you've got a backup.
Exactly.
Okay.
And then stream mode uses a circular buffer in memory.
Okay.
And that's for more immediate analysis and response.
Okay. So if you need to see what's happening right now, stream mode is the way to go.
Right.
Okay. And is it possible to customize which events are actually recorded?
Yeah, the auditing system in AIX is highly configurable.
Yep.
So you can define event recording on a per user basis.
Per user.
So you can say, I want to log these specific events whenever this particular user does anything.
Right. So you can really fine-tune what you're monitoring.
Yeah.
Okay.
And you also have control over the back-end trail processing.
Okay.
So you can choose which audit trail mode you want to use.
Right.
And the documentation really emphasizes the importance of allocating enough disk space for the audit trail.
Yeah, that makes sense. You don't want it to fill up and then stop working.
Right.
So how much space are we talking about here?
So the recommendation is at least 20% of the available disk space.
Wow, that's a pretty big chunk.
Yeah, but it's important.
Yeah.
Especially if you're logging a lot of events.
Right.
And in ban mode, there are a couple of other parameters that you should set in the etc. security YADA config file.
Okay.
So you should set bin mode to panic.
Panic, okay.
And free space to at least 25%.
25%, okay.
And that helps prevent the audit trail from filling up and potentially causing problems for the system.
Right, so you're basically telling the system, hey, if we're running out of space, freak out.
Yeah, pretty much.
Okay.
Better safe than sorry.
Yeah, definitely. Now, looking through all of these audit logs, it can be pretty overwhelming.
Yeah, it can be a lot of data.
Are there any ways to kind of categorize events to make them easier to analyze?
Yeah, so AIX uses audit classes to group similar types of events together.
Audit classes, okay.
And that makes it much easier to define, a set of related events that you want to audit for specific users or groups.
Okay, so it's like, instead of having to look through every single event, you can just say, okay, show me all the events that are related to network activity.
Right, exactly.
Okay.
And some examples of common audit classes are general, which covers things like system state changes and user authentication events.
Okay.
TCPIP, which captures network-related activity, and LVM, which tracks actions related to logical volume management.
Okay, so it's a way to kind of slice and dice the data.
Yeah.
Make it more manageable.
Okay, that's helpful. And what about when you're using workload partitions or WPARs? Does the auditing system function within those as well?
Yeah, auditing can be configured independently for individual WPARs.
Okay.
So you can specify which audit classes should be active for a particular WPAR in its local etc. security audit config file.
Okay, so each WPAR has its own audit configuration.
Right.
Okay.
And the global administrator on the base operating system can also initiate and terminate auditing on specific WPARs.
Okay.
And they do that using the audit command along with the @ flag.
Okay, so they have some central control as well.
Yeah, if they need it.
Okay, great. So we've covered a lot of ground here with auditing. Let's move on to the next section, which is about secure configurations.
Right.
What are some of the key takeaways from this section? So this section focuses on proactive things that you can do to harden your AIX system.
Okay, so it's not just about reacting to threats. It's about trying to prevent them in the first place.
Exactly, yeah. And one of the key tools that's highlighted here is the TCBC command.
TCBC pay, okay.
And that's used to verify the integrity of security-relevant files.
Okay, so it's like a checksum or something.
Yeah, kind of. It compares the current attributes of these files against the information that's stored in the Trusted Security Database, or TSD.
The TSD, okay.
And it reports any discrepancies or potential security violations.
So it's like, hey, this file has changed. That's not good.
Right, exactly.
Okay. And what exactly is the Trusted Security Database?
So the TSD is actually a set of databases that maintains critical integrity information about trusted files on the system.
Okay.
So the primary database is located at etc. security sdtsd.dat.
Right.
And then there's a separate database for trusted libraries at etc. security hsdliblib.tsd.dat.
And these databases store things like file sizes, cryptographic hash values, and digital signatures for these trusted files.
Okay.
So that the TCBC command can detect any unauthorized modifications.
Right. So it's like a fingerprint of the file.
Yeah, pretty much.
Okay.
And then in addition to that, trusted execution, or TE, policies are also stored in the TSD.
TE policies
Yes.
today.
And those define rules for how trusted programs should behave.